All right, today we're going to talk about completing the square. And there's some important vocabulary if you're going to be successful to know about completing the square. The first phrase is the leading coefficient. And for us, that's the number in front of the highest powered variable. And for example, for us, usually like if we have 7x squared minus 2x plus 5, the leading coefficient would be a 7. And completing the square for us basically means putting a quadratic, which means an x squared kind of expression, into what we call vertex form. And so then what you'll see is something like y equals ax minus h squared plus k, where the h and the k are the vertex. And so this vertex thing that we're talking about, like if you look at a parabola, you'll see that we have the opening up parabolas or the opening down parabolas. And our vertices, the vertex, would be the lowest point or the highest point of that parabola. So the lowest or the highest point of the parabola. And that's what we were just talking about when we talked about this HK thing. That's the vertex. So off to the right-hand side here, we see an example of what we're going to do. And so step number 1 for us is going to be putting the x terms into a parentheses. So step number 1, we're going to go with x squared minus 8x in a parentheses, leave some space, and then put whatever's left over on the outside. That's step 1. Step 2, we're going to take half of the middle term. So we're going to take that negative 8, and we're going to divide it by 2. And we get negative 4. Step 3, we're going to take whatever we got, that negative 4, and we're going to square it. So whatever you saw right here is what went in my parentheses to square. Step 4, we're going to rewrite that parentheses now, and we're going to put in what we got in step 3 in the parentheses and outside the parentheses. So now I see this, x squared minus 8x, and then I had a positive 16, so I have plus 16, and there was a minus 12, and whatever I did right here, I'm going to do the opposite on the outside. Because you can't change an expression without, like if it's an equation, you balance it out on either side, like adding 5 to both sides. But since we don't have an equation, what we're going to do is we're going to undo what we just did on the outside. Now if you look inside the blue parentheses, the reason they call this completing the square is what you've just done by having a positive 16 there is you've made this parentheses into something called a perfect square parentheses. So step 5, I'm going to write this in a different form that means exactly the same thing. In other words, I'm going to write this as a parentheses squared. The way that you do that is you look at the first term, which is x squared, and you square root it. So the square root of x squared is x. Then you look at the last term, which is positive 16, and you square root that. What do you get when you square root 16? 4. And then you look at the middle term, and you see which sign was it. Was it positive or negative? Negative. So I put a negative in between them. And then on the outside, negative 12 and negative 16 is negative 28. Now the interesting thing is, if you were to FOIL back out this pink squared parentheses, you would see the blue expanded parentheses. Because x minus 4 times x minus 4 is x squared minus 8x plus 16. But the reason that you've done this is if this happened to be an equation, for example, if I would have written this as y equals x minus 4 squared minus 28, you could tell me right after that that your vertex was at 4, negative 28. And this is why we complete the square. It has to do with graphing parabolas. So we're going to skip number 1. We're going to go right to number 2. Number 2. Actually, number 2 is harder than some of the other ones. So let's try 3 and 4 first. And then we'll come back to number 2. So number 3, if I follow my steps, step number 1 was to write the x stuff in a parentheses. Step number 1, x squared minus 4x, parentheses, and then plus 2, and I have equals 0 now. Now this changes things a little bit because now I have an equation, but I'll do it the same way as in the past so it doesn't get too confusing. What was step 2?
Take the middle term.
Take the middle term, divided by 2, thank you. Middle term is negative 4, divided by 2, and I get negative 2. Step 3, square it. So I take that negative 2, and I square it, and I get 4. Now what? Put that in the parentheses. So, step number 4, I now have x squared minus 4x plus 4. Don't forget about the plus 2. But since I added 4, I have to subtract 4. So whatever I found here gets put in here. That's this number. And you do the opposite here. Next step, I'm going to rewrite this parentheses as a perfect square. So now, when I write this as a perfect square, I look at the first term, which is x squared, and I take the square root, and that's x. I look at the last term, which is positive 4, I take the square root, that's 2. I look at the middle sign, and it's negative, so I put a minus sign in between. On the outside, 2 minus 4 is negative 2, and that's still equal to 0. Now when you solve these, completing the square ones, as an equation instead of just an expression. Like right now we'd be done. We'd have usually like y equals something, or it's just that expression. But we're actually going to solve it. So now there are some extra steps involved. This was just step number 5 that we got done with. So now we have to do a couple extra steps. Next step, step number 6, if we're going to solve it, is we're going to move the 2 that's negative to the other side. So I get x minus 2 squared equals positive 2. And oh man, I see something squared. So I have to undo the squaring, which means I square root. So I square root both sides, get rid of that square. And I get x plus 2 equals, and whenever you square root a variable, the answer on the other side of the equation will always be plus or minus whatever you got. Because the answer could be a positive one of those things or a negative one of those things. And now there's only one step left. And that last step that we're going to do is just to move the 2 over. So my final answer is x equals, when the 2 goes to the other side, it becomes negative 2 plus or minus the square root of 2. And in the dark blue is my answer to what x can be in that equation. Now, I'm going to tell you right now, me personally, I would never use this method to solve this equation. Instead, I would use something else that we're going to talk about tomorrow. Do you guys remember what you could use to solve that equation? Not foiling. It starts with the word quadratic. Exactly, Caroline. The quadratic formula. Much easier to me, at least, for this particular example, to do it that way than to go through a completing the square process. So generally, with number 3, I would not solve this problem this way. They just wanted to show you how it worked. Okay, so error on the board, my mistake. Over here on the left side, that should have been an x minus 2, because that's what was inside the parentheses. And then what that would mean in the final answer, of course, is that instead of having a negative 2 there, that would be a positive 2. Sorry about that. Okay, number 4 in completing the square, this is usually why you'd want to complete the square. You have some kind of quadratic equation, y equal kind of quadratic equation, and what you want to do is you want to put it in vertex form so you can graph your parabola easily. And in this one, same thing as usual, except you have y equals. I know it's an equation, but we're not actually